So after about 5 minutes of the execution, and I really want you guys to try this at your home as well, you can see that it has reading all the files, about all 84,000 data has been read. Then it will start try to do the training, and you can see all of these dots are indicating the trainings of the execution. And after a while, you can see it will be able to creating all of the support vectors, finding the boundaries, creating the maximum margin, and then you will be able to write model file. So it will creating the model file that the name we provided as the model that saves all the support vectors in this model. And once that is done, we will be able to use the model to make the predictions. So how do we make the predictions? We will do SVM learn classify, sorry. CLASSIFY, SVM classify, and you need to provide the following things. First of all, testing file. What is the file that you want to do the prediction? Provide a model name, and then creating an output file name so that it can dump all the prediction result into the file. So what we can do is going to be write the SVM classify. First of all, provide the testing file name that we want to do the testing. So the testing file is going to be the first test31. So this is the file, first test31.txt, and then provide the model name. So the model we create is called model 31. This is based on the name we provide in the earlier SVM learn operation. And finally, we can create a file, say prediction, ction31.txt. So if we do so, it will, first of all, read the file, use the model, and make the prediction. Let's take a look at this. So right now it's reading the model. It will take a while to reading all of those support vectors, creating the model, and then it will start reading the testing data set. The testing data set, we use FIFO cross validation. Since the training data set has about 80,000, the testing data set is giving you another 20,000 of the data. So it will, again, read the model, read the data, and then start to make the prediction. It takes a while to do so. So let's take a look what's happening over here. So you can see that it's reading quite a few data one by one. It will reach that part. So right now it's reading about 10,000 points. So as you can see, it will be able to read all the data and then make the prediction. At the end of the result, it can tell you that the accuracy is about 84%, and then precision records the followings. As you recall, the testing data set that we feed in because we already provide the class. And therefore, it will be able to compare with the class versus its prediction and then give you the accuracy. One more thing I want to point out is that if you look into the prediction or the result files that we created, for every y that we input, it will give it a prediction. If the prediction is a negative value, that's indicating it's a negative class. If the prediction value is a positive value, it gives you a positive class. So that these are the prediction results for all the 20,000 y's that we input as the testing data set. And therefore, you can see that the process of the SVM requires two steps. One is using SVM learn to build a model, and then we use the model to do SVM classify to make the predictions. It is very useful and very powerful. So The whole purpose of this class is that I want you guys to be familiar with SVM, have a software package that you can run SVM when it's needed. And therefore, if we come back to the class slide, what you can see over here is that the training data set and testing data set need to be stored in the following format. First of all, provided the class, and then using the 1, 2, 3, 4 to indicating the attribute, and then provide the values for each attribute. You can see that in the first example, it is a positive class. The first attribute is 0.57. The 10th attribute is 3.32. The 1134th attribute is 0.01. Everything else, like attribute 2, 3, 4, 5, 6, 7, 8, 9, and the rest part of it are all 0. So you can abbreviate your data, looks like that. So the SVM folder in the Google Drive have a real data set, for example, and I actually put that in the Blackboard, so it should be in the same folder of your class video. So you have the experience of using that. I want to make sure you guys do have some hands-on experience, so I designed a class assignment for you guys. What this trying to do is that I want you to train the testing data set. It's pretty interesting. Testing data set has only 20,000 ones. So I want you to train on that one, build a model, and then use the model to predict the training data set. Obviously, the accuracy won't be as good as what we see. Maybe. I don't know. So I want you to tell me. All you need to do is simply try to report to me what is the end result of the accuracy. Submit that as the assignment, and that would be the class for today.